Chapter 10. Kind of had a choice between 9 and 10. Decided to go with 10. A little bit of a break. We've been doing with logarithms and the trig functions. We've been doing some new stuff lately. And though matrices is going to be new to you, it's not too bad. We're going to do a lot of adding and subtracting, multiplying, and finding different things with things that we call matrices. So chapter 10 is all really about matrices. We're not going to cover the whole chapter, just bits and pieces of it, but let's go ahead and get going with matrices. Essentially what matrices are is matrices help us organize information. You know, it's one way for things to, it's one way. I mean, if you think about it, really, it's almost like an Excel spreadsheet is what matrices are. And we want to be able to do different operations with these matrices. So one of the things we've got to be able to do is we've got to be able to identify really kind of the different pieces of each of the matrices and kind of help us understand a little bit about what the matrices are. So first and foremost, when we're looking at matrices, matrices are made up of rows and columns. So going this direction, these are the rows. Okay, that's a row. It's row 1 and row 2. Okay, when we go up and down are the columns. Okay, I'm not going to have enough room, but these are the columns. So rows, like the rows of rows of an auditorium, they're rows. They go across from each other. Columns go up and down. When we name matrices, we name matrices by the number of rows they have, then the number of columns that they have. So this has 2 rows, and it has 3 columns. So we say that this is a 2 by 3 matrix. You always name it by the number of rows that it has and by the number of columns that it has. And again, really what these matrices are doing is they're just allowing us to organize information. I mean, if you look at what we have down here, essentially, you've got sweatshirt, you've got a sweatshirts row, and you've got a shirts row. And you've got small, medium, and large columns. So you can just look at this matrices and say, okay, I sold or whatever, sold 5 small shirts. I sold 1 medium sweater. I sold 1 large sweater. It's just a way to help us organize data and to show different ways to represent them. But again, when we name these, we name them by rows and columns. We say they're 2 by 3s, different things like that when we're talking about rows and columns. So if I have something, let's say we have a 0, 4, 6, 3, 1, 2. This has 3 rows and 2 columns. So this is a 3 by 2 matrix. Again, just a way to organize data. And you're going to need to be able to, name these, because adding and subtracting, multiplying, certain things have to happen with the matrix, and they have to be a certain way. They have to be the same, or they have to have the same number of rows or the same number of columns in order to multiply them or whatever. So being able to kind of give their dimensions, so to say, really is important. Okay, so let's look at a couple other things with matrix and how matrices are done. Matrix are generally named with a capital letter. So this would be, we'd call this matrix A, or just A. It has 3 rows and 2 columns, so this would be a 3 by 2 matrix, 3 rows, 2 columns. Each piece of the matrix is called an element, and you can specify where that element is within the matrix. It's one of the things that this book really likes to do, is it likes to name these specific pieces within the matrix. So they kind of use this thing over here in this, and if you want to read through that, you can certainly do that. But essentially, when you're talking about putting a matrix and you're trying to look at like a specific spot within a matrix, it's National Donut Day. We've got donuts downstairs. Gonna have to go get some of those. Sorry, just got an email. That's exciting. So really, if we've got, let's say we've got a 2 by 2 matrix, the first element would be right here. And I could name that element with subscripts by the number of rows that it has, or by kind of where it's located. It's located in the first row, first column. So we would say that that's A11. If I have a second element down here, this is in the second row, first column. So that element is in the spot A21. You kind of think about the chessboard. If you've seen chess or you've watched chess before, that's kind of the same basic concept. When they talk about moves in chess, they're saying knight to A6 or something like that, or bishop to E4. They're naming where they want to move that element or where they want to move that piece. And it's kind of the same thing here. Rows is first, columns is second. So this would be, element A, row 1, column 2. This would be element A, row 2, column 2. So I could give you, for example, well, let's just use this one up here so I don't have to do another one. But let's just say that I want you to identify the element that's in A32. So what element is in A32? So what element is in row 3, 2? Well, the value of that element is 8, because that's what's in that position. And that's what that then refers to. Okay? Wow, I didn't even look at that. Honestly, I didn't look at that. That's kind of funny. Okay, so name them with capital letters. So we call this matrix A. Each little row, we've got rows and we've got columns. We name them by the number of rows they have and the number of columns they have. So this is a 3x2 matrix. And then we can name each element by using an element, a letter, and then a subscript, where the subscript are rows, then columns, to name those different types of things. Okay. A couple other things about matrix. You can have equal matrices. What are the values of variables in matrix equations? You can have what we call equal matrix. Equal matrix are matrix that have the same dimension. Okay, so we say that these two matrices are equal to each other, one, because we put an equal sign between them, and they have the same number of dimensions. Obviously, you got to put an equal sign between them to be equal matrices, but they have the same dimensions, and the corresponding parts are going to be equal to each other. So if you look at the corresponding parts in A11 and A11, they're both 12. 12 is equal to 12. Well, A12 is 0 and A12 is y, so we could say y equals 0, right? If we look at A21, it's 2x and 14. So 2x has to equal 14, so x is equal to 7, and 10 equals 10. So we got that. So equal matrices, just to be equal matrices, got to have an equal sign between them, and they have to be the same dimension. And then each element that's located in the same spot is kind of equal to each other in specific pieces, and those are what we call equal matrix. Okay, so let's just look at an example here real quick. The entries in the matrix are the number of students on a committee. Column 1 lists the girls, column 2 lists the boys, row 1 lists the sophomores, row 2 lists the juniors. It says find A12, A21, and A22. So A12, A12 is going to be the first row, so that's the number of sophomore boys. That's what it represents. So soph boys is what it represents, and there are 5 of them. A21 represents junior girls, and there are 8 of them. And A22 represents junior boys, and there are 10 of them. So we need to be able to name those different elements within each of the matrices. The next thing we're going to talk about then is we're going to talk about how do we go about multiplying matrices, at least scalar multiplication. We're going to look at multiplying matrices later. Where we're multiplying 2 matrices together, but what we're talking here is we're just going to say, okay, let's talk about just what we call scalar multiplication. Scalar multiplication is essentially multiplying each element in a matrix by a single number, okay, called a scalar. Okay. So you can take each matrix and you can multiply it by a different scalar. So in the representation that we have right here, it says Cool Threads, a clothing store, uses a matrix C to represent the prices of women's clothes. So there are all their prices for their women's clothes. The columns represent the brand, vintage, casual, dressed, and the rows represent jeans and jackets. If if the sales tax is 5%, how can you use a matrix operation to find the sale amount of each item? So essentially, we have to take each item times 5%. That's scalar multiplication. We're multiplying something times our matrix. So that means that we need to take each element of that matrix times whatever that scalar is. In this case, our scalar is 0.05. So we're going to take 0.05 times our matrix. So essentially what we're doing with this one then is we're going to say 0.05 times each of these pieces. 320, 240, 210, 110, 160, and 65. Okay. Now the nice thing with Excel, in Excel you could just write one rule for this and you could do it all. We can't do that, so we get out a calculator and go 0.05 times 320. That gives me a 16. 0.05 times 240 gives me 12. 210 is 10.5. 110 is 5.5. Duh. 160 is 8. And 65 is 3.25. And that's scalar multiplication. So you're multiplying a scalar, a single number, times each element in the matrix to create a new matrix. So essentially that's what the sales tax would be for each of those items. Now, is it the total cost? No. Could we find the total cost? Yes, by adding them together. And we're going to talk about that here in just a little bit, how we go about adding those together. But let's look at another example of that, and I'm going to have you go ahead and do this one. I'll whistle. Press pause. Go ahead and do this one. See what you get. So there's our new matrix, if there was a 6% tax placed on it. Okay, now that we've got that, now that we've got the $75 item that has a $4.50 tax, how do we go about adding matrix? And that's the next thing we're going to look at, is go ahead and we're going to add these matrix. So adding and subtracting matrix. Anytime you're adding and subtracting matrix, what you have to make sure that's happening is the matrix have to have the same dimensions. In order to add or subtract them, they have to look exactly the same. A 2 by 3 and a 2 by 3, a 3 by 3 and a 3 by 3, a 4 by 4 and a 4 by 4, a 10 by 10 and a 10 by 10. You can only add and subtract matrix that have the same dimensions. So if they don't have the same dimensions, you can't add them together. And really, when you're adding them, think about it. I mean, you're adding the row with the row. You're adding the element A11 to element A11. A12 to A12, A13 to A13. So you're kind of matching them up, adding them together, or subtracting them from each other and completing the operation. So essentially here, what are the total sales for the 2 months? It gives us March sales, it gives us April sales. So we're going to add the two elements together. So a lot of times what you'll see in the book is you'll say they're going to take A and you're going to add B together. So kind of just this first time, that means that I'm going to take 14 plus 18. It means that I'm going to take 10 plus 16. I'm going to take 11 plus 17. I'm going to take 28 plus 25. I'm going to take 15 plus 9, and I'm going to take 35 plus 45. And that's going to be my matrix of total sales in this case. So 32, 26, 28, 24, 53, and 70, 80. Okay. What does it represent? Well, it represents that we sold a lot of distressed jeans, okay, during the month. Okay. So adding two matrices together, don't overcomplicate it, element to element. Be careful when you're doing it to make sure that you line up exactly what needs to be lined up. But yeah, make sure you line things up and be a little bit careful with it. Do I expect you to write it down like that every time? Gosh, no. But just be careful to make sure you add up A11 with A11, A12 with A12, and so on and so forth. Okay. This case, how do you go about subtracting them? Cool threads again. March sales, it says what is the difference between the items sold each month. So we're going to subtract them. Could you subtract them in either direction? Yeah. They would probably tell you, which they want you to do, what's the difference. We're just going to go ahead and just do A minus B. So 14 minus 18 is negative 4. 11 minus 17 is negative 6. 28 minus 25 is 3. 10 minus 16 is negative 6. 15 minus 9 is 6. And 35 minus 45 is negative 10. Okay, so this is the difference between March sales and April sales. So we sold 4 more. So if we're representing, talking about it, we sold 4 more in April than we did in March. But subtracting them, and just subtract them, and subtract the elements that match up with each other. Okay, let's look at a couple more, and I'm going to have you do these. If you're good to go, you can add them, move on to the next part of the video. Otherwise, go ahead and do these things, and the answers will appear in about, you're probably going to press pause. When you unpause, the answers will be there. In 3, 2, 1, go. All right, there are your answers. All right, the next thing then we're going to look at is a little bit bigger ones. And we're going to add a little bit maybe not some terminology in here, but just kind of talk about what we can do and what we can't do. Question here, looking at all of those different matrices, it says, which matrix can you combine using addition and subtraction? Okay, so again, I talked about it earlier. In order to add or subtract matrices, they have to be exactly the same dimensions. So if we look at the dimensions of this dimension is 2 by 3. This dimension is 3 by 2. This dimension is 2 by 3. And this dimension is 2 by 3. So we could add or subtract A, C, and D. We could not do anything with B with any of these matrices that we have right now. They have to have exactly the same dimensions in order for them for us to add or subtract them. Okay? Pretty straightforward. We're not going to add any of them. We just showed that you could add. We should get some terminology here now taken care of. The next thing we're going to talk about is we're going to talk about what we call a matrix, what we call a zero matrix. A zero matrix, and it's down here, when the sum of two matrices is a zero matrix, the matrices are what we call additive inverses. So there's two key words in here that you need to know and that you need to understand. The first one you need to understand is what a zero matrix is. A zero matrix is just a matrix where everything is zeros. Zero matrix, where all the elements are zeros. So when we take two matrices and get a zero matrix, those two matrices are what we call additive inverses of each other. Okay. They're what we call additive inverses of each other. So if we look at what's happening, in this case, A and D added together to create that zero matrix. So A and D are additive inverses of each other. And if you look at 5 and negative 5, and A1, 1 and A1, 1 in both of these, and you kind of go along the line and look at those elements, what do you notice, really about those elements? Well, they're opposites of each other. Okay, and that's what an additive inverse is. An additive inverse, we've always said that an additive inverse of a number makes the number 0. So 5 plus negative 5 is 0. So negative 5 and 5 are additive inverses of each other. Okay, when you take two additive inverses and add them together, you get what's called a zero matrix to that. Okay, so here's another example really of what an additive inverse is. Okay, so it's asking us what is the additive inverse to B in this case. And well, if you look at B and we just kind of think about it, here's B, and I know they wrote it down there, but if I want to know what the additive inverse is for B, all I have to do, they make it a lot more complicated down here than it probably needs to be. All you have to do is change the signs of each of the elements in the matrix. So 6 becomes negative 6, negative 2 becomes 2, 3 becomes negative 3, 5 becomes negative 5, 0 stays 0, negative 4 becomes 4. So these two things are additive inverses of each other. You're essentially taking your matrix and multiplying it by negative 1, and that's an additive inverse. Okay. So let's go ahead and look at a couple of examples. And we'll do these, and we'll just do some of them. It says, find Q minus R. And then what other matrix sums or difference could be calculated. So we're going to do R and Q. There's really nothing else we could do except for this subtraction because we've got a 2 by 3, a 3 by 2, and a 3 by 2. So Q, R minus Q, or we could go Q minus R, are the only ones we could do. So it asks us to do the difference, so we'll do the difference here real quick. So R minus Q, so 6 minus 2 is 4. 5/10 minus negative 2 is 2.5. Negative 3 minus 5 is negative 8. 0 minus negative 5 is 5. Negative 2 minus negative 7 is 5. Negative 2 minus 7 is negative 9. Okay. So there is R minus Q, and then we just talked about which ones are the ones we could calculate. Additive inverse, we're just going to do what's the additive inverse of P. Additive inverse of P would just be negative 5, negative 7, 2, 0, 3, and 5. Just switch the signs. All you have to do for additive inverses. Okay, so the operations we have within matrix, and we've kind of talked about all of these. how you get the dimensions, how you get the different elements by rows and columns. Remember, rows go across, columns go up and down. Scalar multiplication is just taking the number, your scalar, times each element in it. And then when you add or subtract the matrix, add the same elements of each other. And then additive inverse, just multiply your original matrix by -1. Okay. If you're good to go, you can go ahead and get working on the assignment. The assignment for today is page 509. You are going to do 13 through 14. You're going to do 13, 14, 19 through 28, 32, 34, and 35. Okay, if you're good to go on your assignment now, hit the end button, hit stop, which you've probably done already, and you're good to go. If you still need a little bit of extra help, I've got about 5 or 6 additional questions I'm going to look at to make sure that you're okay. And some of the ones that you're going to look at kind of in your assignment. So again, if you want to press pause, if you want to be done and you're good to go and you're comfortable with everything, go ahead, start on your assignment. If not, I'm going to go ahead and do, looks like probably 5 more examples, just kind of all of the things that we've covered already, just to make sure that you're okay. Have a great weekend, everybody. You're either watching this on a Thursday or a Friday. Have a good weekend. We'll start talking multiplication of matrices next week. Okay, if you stayed around, thank you for staying around. It's good to see you again. Let's make sure that we've got everything done and taken care of. And the sun just came out. I haven't got a donut yet, but still thinking about the donut. Sun just came out and is blaring in my eyes, but whatever. So this first one, it says identify the element A23 for the matrix. So we're looking for the element that's in the second row, third column. Rows go up and down, columns go, rows go left to right, columns go up and down. So second row, third column is 5. Just circle it, it's easier. Next one. It asks us to calculate A plus B. And if you want to do it by yourself, I suggest you press pause because I'm just going to keep going. But if you want to do it before yourself, prior to, just hit pause now, and then you'll get the explanation here in just a second. So if we take A plus B, we add 3 plus 0. First we check 2 by 2 and 2 by 2. Perfect. So your 3 plus 0 is 3. Negative 2 plus 7 is 5. 7 plus negative 4 is 3. And 13. 2 by 2 plus 2 by 2 gives you a 2 by 2. Combine the columns. Next one, given A and B, calculate B minus A. Make sure you read it, right? B minus A. B minus A is different than A minus B. So B minus A, so 0 minus negative 3. 0 minus 3 is negative 3. 7 minus negative 2 is 9. Negative 4 minus 7 is negative 11. 12 minus 1 is also 11. There's our matrix. The next one, given A and B, says calculate 4A. Again, press pause if you want to do it yourself first. So we're going to take 4 times A. So I'm going to take 4 times each element of A. So 4 times 3 gives me 12, negative 8, 28, and 4. And then the last one, given those two, calculate A minus B. 3 minus 0 is 3. Negative 2 minus 7 is negative 9. 7 minus negative 4 is 11. And 1 minus 12 is negative 11. So there it is. Okay, if you have to scroll back to get the assignment written down, I'll just do that for you right there. You got the assignment. Again, like I said before, if you stuck around and did these extra examples, thank you for doing that. Give me a like. Or don't. I don't care. Have a great day. Have a great weekend, everybody. See you next time.